Hello class, in this video I'll be introducing combinations. Let's begin. To recap, a permutation is a selection of R objects out of N, where each arrangement of the R objects is different. The arrangements of A, B, and BA are different and count as two permutations. You will sometimes hear the phrase, order is important. And that just implies that the arrangements AB does not equal the arrangement of BA. All right. On to combinations. A combination is a selection of R objects out of N where each arrangement of the R objects is the same. The arrangements of AB and BA are the same and count as one combination. You may hear the phrase, order is not important. And all that implies is that the arrangement AB is the same as the arrangement BA. All right, with that said, let's take a look at the formula. If C of n comma r denotes the number of combinations of n elements taken r at a time, then the total number of combinations is n factorial divided by the quantity n minus r factorial times r factorial. And for the next three examples, what I'm going to do is I'm going to identify whether the example is a permutation or combination and then use the appropriate formula. Starting with example 1. An economics club has 25 members. If a committee of 4 is to be selected, in how many ways can the selection be made? All right, so what we were looking for is a committee of 4. And my claim is that this is a combination because each arrangement of the 4 committee members is the same committee. And in this case, what they would say, order is not important. And that implies AB is equal to BA. And now that we know this is a combination, I can write C of 25 comma 4, and that is equal to the following. Now this can either be solved by hand or by Desmus. I would suggest solving this on Desmus, so we're going to do that now. All right, starting with using the factorial notation, that is going to be 25 factorial divided by 21 factorial times 4 factorial. That's 12,650. What you can also do is go over here to functions, hit NCR, and it's 25, choose 4. And you get the same result. Now, no matter how you do this on Desmus, you must show all of this work to get full credit. So there are 12,650 ways to select the 4-person committee. Okay, part B. If the club wanted a president, vice president, secretary, and treasurer, how many ways can this happen? All right, my claim is that this one is a permutation. And that's because if A was president and B was vice president, that is not the same as A being the vice president and B being the president. So here, not the same arrangements. All right, since these arrangements are not the same, we're going to conclude that this is a permutation, and we're going to go P of 25, comma 4. And that is equal to the following. And after using Decimus, you'll see that there are 303,600 different ways this can happen. Okay, and on to the last one. 6 cards are dealt from a standard deck of 52 cards. And how many ways can a hand of 6 clubs be dealt? Okay, my claim on this one is also that it is a combination. And I say that because each arrangement of the 6 clubs is the same hand. All right, with that said, let's figure out what's going on. So we need to select 6 clubs out of 13 in the deck. Also, we need to select 0 cards from the remaining 39 cards. All right, so that can be determined by doing the following. First, we're going to take 13 and we need to choose 6. Then we need to take 39 cards and choose none of them. So I'm going to set up each of the formulas. So the first one is 13 factorial divided by the quantity 13 minus 6 factorial times 6 factorial times the following, 39 factorial divided by 39 factorial times 0 factorial. And after all calculations, you will get that there are 1,716 different hands of 6 where all 6 are clubs. And we are done.